Welcome to our channel. As we've highlighted in previous videos, Advanced Steel allows us to create highly detailed structural models in a fraction of the time it would take using traditional AutoCAD tools alone. This includes primary structural elements such as columns and beams, but also more complex components like trusses or metal stairs, all of which can be fully detailed by adding subcomponents such as bolts, plates, welds, and essentially everything required for fabrication. Nevertheless, and beyond 3D modeling, Advanced Steel truly stands out when it comes to the fast and automatic generation of detailed drawings. For example, let's quickly obtain an elevation view for one of the structures in this project. Unlike AutoCAD, this can be done with just a few clicks. So let's go ahead and request a new elevation view for one of these structures. Here, for instance, we're asked to define the base template that will be used to generate the drawing. In this case, it's worth mentioning that we've already configured a drawing template specifically for this project. This template includes settings such as drawing scale, paper size, the type of details to be displayed, and a title block that can be fully customized to match our project requirements. So just as we've seen in previous videos, Advanced Steel allows us to fully customize the detailing and documentation process, which in turn allow us to automate it and significantly decrease the time needed to complete it. Let's proceed, then, and select the template we've already configured. And with the process now completed, let's take a look at the results. As we can see, with just a few clicks, we've obtained not only the elevation drawing for the selected structure, but also the corresponding table of structural components that make up the system. It's also worth noting that this drawing goes beyond a simple elevation view. It includes important information such as the overall dimensions of the bridge, as well as elevation levels for the main structural elements. Additionally, for each steel section, the position of its central axis is clearly defined. This is especially important when placing additional dimensions throughout the model. We can also quickly add labels to properly identify each structural element based on the information shown in the table. Now, while all of this is extremely useful within Advanced Steel, compatibility with other CAD platforms such as AutoCAD is also very important. For example, let's say we want to open this drawing directly in AutoCAD or in any other DWG-compatible software. To do this, we'll go back to the Document Manager. From here, we'll select the Add to Explode option. What this does, and as the name suggests, is convert the drawing generated by Advanced Steel, which is currently linked to the 3D model, into simple 2D line work. More specifically, Advanced Steel creates a new DWG file that can be opened and edited in any standard 2D CAD application. So let's continue and locate the resulting file. Here we have the final drawing. At first glance, it looks almost identical to the one generated directly in Advanced Steel. However, once we click on it, we'll quickly notice that these elements are now simple lines, fully editable. We can move them, trim them, modify them, or adjust any structural component as needed. So once again, we can clearly see that Advanced Steel not only accelerates the modeling process, but also provides a highly efficient workflow for detailing and documentation. At Virginia-e-Learning, this is exactly the type of workflow we focus on teaching, helping you move beyond manual drafting and toward professional, production-ready structural steel detailing using Advanced Steel. If you'd like to learn more, be sure to visit our website where you'll find multiple Advanced Steel courses built around real industrial projects and practical use cases. And don't forget to subscribe to the channel for more videos in this series, where we explore tools, workflows, and best practices for structural steel modeling and detailing in Advanced Steel.